The story of aviation has always been one of bold ambition, engineering brilliance, and the drive to overcome the impossible. From the first fragile gliders to the roaring jet engines of the 20th century, humanity has pushed the boundaries of flight again and again. And now, in the 21st century, we are entering a new frontier, a revolution driven not by speed or altitude, but by sustainability, efficiency, and advanced propulsion technologies. Hydrogen and electric aircraft are no longer concepts for the distant future. They are here, evolving rapidly, and they promise to reshape the way we think about air travel. Before any powered flight, inventors and dreamers were already imagining ways to lift humans into the sky without relying on fossil fuels. Electric motors were experimented with as early as the late 19th century, but limitations in battery technology made sustained flight impossible. Even pioneers like Otto Lilienthal, whose gliders in the 1890s proved the principles of lift and control, could only imagine a future where clean, efficient flight might be possible. Lilienthal's work, tragic as it ended with his death in 1896, laid the foundations for understanding aerodynamics, which remains critical for hydrogen and electric aircraft today. The first powered flight in 1903 by the Wright brothers marked the beginning of modern aviation. Their Flyer achieved just 12 seconds in the air, but it demonstrated that controlled, sustained flight was achievable. In the decades that followed, aircraft evolved rapidly. Engines became more powerful, designs more efficient, and commercial aviation emerged. Yet throughout the 20th century, aviation relied almost entirely on fossil fuels. Jet engines, propeller-driven planes, and even early experimental aircraft depended on gasoline and kerosene. The environmental impact was largely overlooked, and efficiency was measured in speed, range, and payload, not sustainability. That perspective began to change in the late 20th and early 21st centuries. Rising awareness of climate change, carbon emissions, and fuel scarcity forced the aviation industry to rethink propulsion. While incremental improvements like composite materials, aerodynamic refinements, and more efficient engines helped, the underlying problem remained. Conventional aircraft burn millions of liters of jet fuel each year, contributing significantly to global CO2 emissions. This challenge opened the door to alternative propulsion technologies, and today, hydrogen and electric aircraft are at the forefront of this transition. Electric aviation has seen rapid progress thanks to advances in battery technology, lightweight materials, and computer-aided aerodynamics. Small, light aircraft were the first to benefit. Experimental models like the Pipistrel Alpha Electro, a two-seat training aircraft, demonstrated that electric motors could safely and efficiently power short flights. Unlike traditional combustion engines, electric motors are quieter, smoother, and mechanically simpler. The absence of complex gearboxes and fuel systems reduces maintenance costs and increases reliability. For training and regional flights, electric aircraft are already proving viable, and companies are scaling up designs for larger commercial applications. The core challenge for electric flight, however, remains energy density. Current lithium-ion batteries store far less energy per kilogram than jet fuel, which limits flight range and payload. Engineers are exploring solutions such as solid-state batteries, hybrid electric systems, and distributed electric propulsion to overcome these constraints. Distributed propulsion, for instance, uses multiple smaller electric motors along the wings or fuselage, improving lift, reducing drag, and enhancing efficiency. Aircraft like the Lilium Jet are leading the way, using multiple ducted fans to achieve vertical takeoff and landing while remaining entirely electric. These innovations are not just about performance, they're about reimagining what flight looks like in a sustainable future. Hydrogen, on the other hand, offers a different path. Hydrogen fuel has one of the highest energy densities by weight of any known element, making it extremely attractive for aviation. It can be stored as a compressed gas or in liquid form, and when combined with oxygen in a fuel cell, produces electricity with only water as a byproduct. This means zero carbon emissions during flight. Companies such as ZeroAvia, Airbus, and Universal Hydrogen are pioneering hydrogen-powered aircraft, targeting regional commuter planes and cargo aircraft initially, with plans to scale up to larger commercial jets in the coming decades. The design considerations for hydrogen aircraft are unique. Hydrogen must be stored at extremely low temperatures if liquefied, or at high pressures if gaseous. Aircraft structures must accommodate tanks, fuel lines, and safety systems without compromising aerodynamics or payload. Hydrogen is also less energy dense by volume than kerosene, requiring careful design of wings, fuselage, and overall aircraft geometry. Despite these challenges, prototypes like the Airbus ZeroE concept illustrate that hydrogen propulsion is feasible and scalable. With flight ranges comparable to current regional aircraft, hydrogen could revolutionize short and medium-haul aviation first, before gradually expanding to longer routes. The environmental benefits of hydrogen and electric flight are profound. Aviation contributes roughly 2 to 3% of global CO2 emissions today, with regional and domestic flights being particularly polluting per passenger kilometer. Electric and hydrogen aircraft could reduce or eliminate these emissions, especially for short-haul flights that represent a large portion of daily flights worldwide. Noise pollution is also dramatically reduced. Electric motors are far quieter than combustion engines, making urban air mobility and regional air transport more compatible with densely populated areas. The economic impact of electric and hydrogen aviation is huge. Analysts predict the electric aircraft market could reach tens of billions in the next decade, with hydrogen aviation following as production scales. Airlines, airports, manufacturers, and governments are investing heavily in infrastructure. Battery charging, hydrogen refueling, and AI-assisted maintenance. Early adopters gain advantages in cost efficiency, regulation, and environmental branding. AI is key, optimizing flight paths, predicting maintenance, and managing energy in real time. Advanced battery and fuel cell monitoring, plus autonomous flight systems tested in drones and small aircraft, will further cut costs and boost safety in sustainable aviation. The shift to hydrogen and electric aviation won't happen overnight. Challenges like infrastructure, regulation, and public acceptance remain, while hydrogen production needs scaling with green energy and batteries require higher energy density. Certification standards must evolve for safety and new propulsion systems. Yet innovation and investment are accelerating progress. History shows each aviation leap, early flight, the jet age, digital navigation, solved past limitations while creating new possibilities. Today, electric and hydrogen aircraft aim to solve emissions, noise, and sustainability, redefining flight itself. For creators, AI slideshows can trace this evolution, from early experiments with Pipistrel or ZeroAvia to Airbus and Boeing's hydrogen projects, illustrating a future where quiet, emission-free aircraft dominate our skies. The cultural shift is just as profound as the technological one. For over a century, aviation has been synonymous with roaring engines, exhaust fumes, and long-haul fuel stops. Future generations may associate flight with quiet electric lifts, zero-carbon propulsion, and intelligent AI systems managing every aspect of performance and safety. The psychological impact of this transformation should not be underestimated. Flight is no longer just a marvel of engineering. It becomes a statement about sustainability, innovation, and the possibility of a cleaner planet. From the early gliders to the first electric trainers, from experimental hydrogen prototypes to the Lilium jet and beyond, aviation reflects humanity's relentless drive to improve, innovate, and explore. The challenges of climate change, fuel costs, and environmental responsibility are driving innovation faster than ever. Hydrogen and electric aircraft are not just technical achievements, they represent a philosophical shift where aviation is aligned with planetary stewardship and future sustainability. Looking ahead, hybrid electric regional aircraft and hydrogen-powered short-haul jets will operate alongside conventional planes, while urban air mobility corridors enable fast, quiet, and sustainable travel over cities. AI-assisted flight control, predictive maintenance, and autonomous cargo operations will cut costs and boost safety. With continued government and private investment, sustainable aviation is moving from prototypes to reality. Flight is no longer just about speed or distance, it's about efficiency, quiet, and clean travel. From early gliders to modern hydrogen and electric aircraft, the sky's potential now combines power with responsibility and sustainability. From the earliest experiments in battery-powered flight to hydrogen-fueled prototypes ready to take off, the trajectory of aviation tells us that innovation never stops. Each technological leap builds on the lessons of the past while opening new possibilities for the future. Just as the Wright brothers transformed the 20th century, electric and hydrogen aircraft promise to redefine the 21st century. And while no one can predict every detail of what air travel will look like in 2030 or 2050, one thing is certain: humanity's desire to fly farther, cleaner, and smarter will continue to drive aviation into bold, uncharted skies. The revolution of flight in the 21st century is not just about machines, it is about vision, responsibility, and adaptation. Hydrogen and electric aircraft are the embodiment of this evolution. They represent the convergence of advanced materials, artificial intelligence, and sustainable energy. And just like the pioneers who shaped aviation over a century ago, today's engineers, designers, and innovators are laying the foundation for a future where flight is not only possible, but clean, efficient, and aligned with the planet's needs.